maybe here some 25, 26 degree, whatever temperature, and etc. etc. Then the next photo. Yeah, this is the water cooled condenser. And this is water flow meter. You can read it over here 4, 10, 20, 30, 40, 50. So this is in gram per minute or gram per second, whatever. Okay. And this is the refrigerant part. So here also you can see this indicator. Here this is the indicator. If it is at the bottom, that means zero flow, correct? So adjusted flow for some particular m dot here and here. Fine. This is the gauge for the evaporator. And the next photo. Yeah, here you can read condenser. The condenser pressure. So you can see this is kilonewton per meter square. That means kPa, basically, correct? And that is up to 2000. This is condenser part, and the evaporator part. Yes, this is up to 1200 only. Same kilonewton per meter square. So the scales are different. Here you can observe for the evaporator, even minus scale is also given. We never use it, as we had discussed, because otherwise the leakage problem would be predominant. The moisture will enter into the evaporator and chokes everything. But being the closed circuit, if you are confident about the leakage problem, then you can use the evaporator at even the negative part. Correct? So 0 means 1 atmosphere. This is a gauge pressure. We have to use the absolute pressure. So 0 means 1 atmosphere, lesser than that. So that is something in the vacuum. Fine. This is the refrigerant flow meter. So you can see, can you read the scale? This is 6, this is 8, this is 10, this is 12, 14, 16. And like that. So we adjusted it somewhere at 5. 5 gram per second. So this is for the, and this is the condenser part, water cooled condenser. And then, yes, this is that water part. So you can read 20, 30, 40, 50, same. Then, okay, photos over. So now just to wait for this thing, video.
Hello, sir.
Huh.
Sir, you can directly play the video on Google Drive. That means Classroom.
I'm doing the same thing.
Okay.
हे चालेल का आता? बघू ना. हे का? थांबा हा. मग आधी आपल्याला काय करायला लागेल? स्क्रीन शेअर. अच्छा. कुठे गेलो ते? नाही ह्याच्यात आहे, सॉरी. हा, कॅन यू सी दिस?
Yes, sir.
हा. I reduce the m dot. If I give higher m dot. Can you see this?
Yes, sir. Yes.
You will see some reflections over here, and what we have to even here also. This what one indicator, that mark. And it's somewhere shifted over here between 3 and 4 something. Okay. And after certain time you have to observe here. And simply if it is this, fine, working. This is your thermostatic expansion valve, correct? So that is my H3 is equal to H4. So if you observe it from the pH chart, your pressure is reduced, condenser pressure to evaporator pressure, and the temperature also reduced. So that cooling part will be sensed over here, and then it will absorb the heat from the evaporator, which is those black tubes. Okay, so that is what is being shown. So you have just started the unit. So you can read over here certain evaporator load Then over here, different temperatures. What he is holding with the hands is a knob, so that I can get the reading of T1, T2, T3, T4, etc., etc. Okay, different temperatures. So he rotates the knob, and accordingly you will get the temperatures. This is the load, that means wattage, and here at the bottommost part it is the RPM for the motor. Okay, so wattage, temperature, and motor speed. Here there are two knobs. If you put it on the downward side, it will be the evaporator wattage. If you put it on the upper side, it will be the motor wattage, means basically compressor part. So compressor wattage, compressor चलाने के लिए भी power चाहिए. So you shift the knob on the upper side, it will give you compressor power. If you put it on the downward side, it will give you the evaporator wattage, DC power. Fine. It's just a multi-shift knob. Fine. Any doubt?
Yes, sir.
Okay. He's observing, or rather adjusting the zero mark for the dynamometer reading, so that whatever force you are getting as a force on the shaft of the compressor into the displacement of the piston, that will give you the power. Basically work per unit time, that is power. Correct? That is what he is adjusting. Zero mark. Here you see it is somewhat 100, 150, so 160 and something like that. And here it is somewhat negative side. Condenser is positive portion, evaporator negative. We may get something going. You can read 25.4 degrees Celsius. Okay, some temperature, maybe T1. Then 777, that is RPM, speed. And then 5 at evaporator load. Fine. This is the starting point. Fine with this. Pressure just now I have explained. This is somewhat negative, maybe minus 25 kPa. This is gauge, not absolute. And over there somewhat 150, 160 jo bhi tha. So 160 kPa condenser side, minus 25 kPa evaporator side. That much is your pressure ratio. Fine. Any doubt?
No, sir.
So that means circle refrigerant is there. Okay. Now what you can observe here is the temperature. So this is T1. T1 means what is it? The knob. You get T2. And this is RPM 777. And evaporator input we have to give. So he will give that evaporator. Right now it is 5 watts. So he will give some 100 watts, 50 watts. See here you can see he is giving the evaporator input. So this is now 5 watt था पहले, अभी 73 watts हो गया. Can you see this? DC 75, 80, 90, 97, 100. Okay, so we finalized for around 100 watt as the evaporator load. So finding out COP becomes very simple. Compressor calculations, that is compressor input, and that is denominator part, and this is numerator, evaporator input, that is directly known. I need not calculate for m dot into delta H and etc. etc. Directly given. This is DC supply. Fine. Any doubt?
No, sir.
You can see over here the fluctuation 105, 108. That is the evaporator load. Here are the temperatures. Now he will show you the temperature variation T1, T2, T3, T4, T5 and T6. See here, this is 317. Whatever he had just shown you, that is the motor input. हाँ, कितना दिख रहा है 316 or 318, whatever. That is the motor input. And what we had given as the evaporator input is whatever 105, 106 जो भी था. So this switch acts as a double way. On the upper side it is the motor input, and on the lower side it is the evaporator input. I can use the same switch connected in two ways. Okay, is it fine?
Yes, sir.
इसलिए कम आ रहा है ना तो किस तरह है त्याच्यामध्ये आधी हिंदू लगायला वगैरे थोड़ा मध्ये आलं तर बंद
After the compression it has to be higher side. Your inlet temperature for the compressor was something 27, whatever it is, and the exit temperature naturally will be somewhat larger, greater, correct, after the compression. So that we tried to find out. The knob was having some problems, so either it is 30 or 34 or 39, whatever it is. But some was greater than 27 because the refrigerant itself left inside the system is very, very small. So, like pressure itself is not getting developed. So, how much temperature change we expect? If there is no pressure, if the condenser and evaporator at the same pressure, that means no temperature difference also, no? So, what we fortunately got today, some gas was there inside. I was afraid कि कुछ भी नहीं होगा तो क्या दिखाने का, but some gas was there. So at least we could start the setup and show some readings. They are not accurate. I will share the readings afterwards, but I want you to just see how the system works. I want you to understand how the readings are taken and etc etc, because values can be anything. Values don't matter as such. करेक्ट, वैल्यू में आपको कुछ भी दे दूं, आप कैलकुलेट बाद में कर सकते हो. I want you to understand how the values are taken. So that is why the video is made for you people to understand the setup, understand how the readings are taken, etc etc. It doesn't matter whether it is 30 or 34 or 39. बाद में. Okay, value is not so important. It has to be greater than 27. That is important. Do you agree or not?
Yes, sir.
Right. Whatever is your T2, त्याच्यात गॅसच नाही जास्त.
P3 करू
हां, सगळं त्यांना दाखव. ते जाणारच आहेत ते, जास्त येत नाही.
P3
T3 is after the rejection. So it has to be now again 27. T3 is after the water cooling, correct? Condenser, water cooling. So 30 का फिर से नीचे आ गया, 27. T2 is compressor outlet. That means condenser inlet, and condenser is water cooled. So 30 में से heat reject हो गया and it comes back to 27. Correct or not? What happened?
Sir, can you say that again, sir?
What? सब आपके सामने ही है. शेयर क्या करना है?
No, sir. I thought your voice was breaking, sir.
No, I asked a simple question. It is a water cooled condenser whose inlet is 30, so outlet has to be lesser than 30, no?
Yes, sir. Yes, sir.
So that is 27, whatever it is showing right now.
P4
And here you see 25.3. This is after the expansion. That means throttle inlet, whatever 27, throttle outlet 25. It has to be lesser than, correct?
Yes.
So inlet condition 27 degree, outlet condition 25 degree. So that is a cooling. So as we can see, very, very small amount of cooling. Because system में गैस है ही नहीं, थोड़ा बहुत है, आपका नसीब अच्छा है, इसके लिए वो चला. Otherwise generally what happens is it gets stripped off immediately. अगर गैस ही नहीं है तो नेचुरली ट्रिप हो जाएगा. आज आपका नसीब अच्छा है, कुछ तो था गैस. So let's say 27 compressor inlet, 30 compressor outlet, which is condenser inlet. Naturally, after the water circulation, heat rejection, 30 comes back to 27. That is condenser exit, and condenser exit is your throttle inlet. So that is 27, and throttle exit is even further lower temperature, that is 25. Then it will absorb the heat from the evaporator, or rather in the evaporator, from 25 again back to 27. So this is how cycle completes. 27 to 30, 30 to 27, 27 to 25, and again 25 to 27. Fine.
Yes, sir.
Okay. Fine. Very good. Just a minute. काय हे? म्हणजे हे का? मग हे आता लावल्यावरती चालेल, कारण हे सरांचं आहे, मी आपलं असंच घेऊन चालवतोय ते. बरं हे काय टेस्ट करायचं आता, म्हणजे लॅब चालू आहे. हो, कारण हे बंद केलं की बंद पडणार बर ठीक आहे चालेल. मग मी हे बघतो, काय व्यवस्थित असेल तर प्रश्नच नाही, नसेल तर मी ह्यांना सांगतो. आणि ते दुसरं काहीतरी होतं ना, काय बरं, बॅटरी होती. हा, ते याची बॅटरी, ह्याचाच मेन प्रॉब्लेम येतो, म्हणून मला हे लावून चालू ठेवायला लागतं. हा बरं ठीक. Okay, let us start the video again. So temperature further reduces. 25 and then again coming back to 27 or 28.
25.
This is water inlet. This is your water inlet, cooling water.
26.
So 25 is your inlet condition and 27 or whatever it is, 28. That is the exit condition. 27 it is a cooling water, so naturally water gets heated, refrigerant gets cooled. So 25, let's say, is your water inlet, goes to 27, heating, correct? T5 and T6. T5 is lower, inlet water, T6 is higher, exit water temperature, correct? Are you getting or not?
Yes, sir.
कंडेंसर कूल हो रहा है मतलब वाटर गर्म होगा ना, वाटर टेम्परेचर बढ़ेगा, सो वाटर इनलेट इज लोअर, वाटर एग्जिट इज हायर. It depends on the mass flow rate. If I put the mass flow rate higher, temperature difference is
27.
कमी लागणार.
हा. 36 पर्यंत जातं. नंतर हे घ्यायचंय, मोटर इनपुट.
See, motor input is 3112. Then the pressures, the condenser pressure is around 200. Evaporator pressure is minus 25. Minus 25 kPa, this is plus 200. Are you getting it? This is plus 200 kPa condenser, and evaporator जो नीचे है, that is minus 25, zero के नीचे. So this is how we take the readings. Any problem to anyone?
No, sir.
22 grams per second water flow, and this is 3, 4, 5 grams per second refrigerant. So we have taken the mass flow rate readings for the water, that is 22 grams per second, and mass flow rate for the refrigerant, that is kitna tha, 5 grams per second. Fine. Mass flow rate of water is required for the condenser heat rejection. Earlier experiment, same logic. Whatever heat rejected by the condenser is the one which is absorbed by the water. So m dot into Cp into delta T. That is the condenser heat rejection. That doesn't come into the COP, but we have to know it. Correct?
Yes, sir.
And next part.
7 point आहे. तेव्हा इकडे.
This is the spring balance, which is calibrated in terms of newtons directly. So you use it directly because the length of the dynamometer arm, that is known to me. So directly calibrated in terms of Newton, that is force. Force into displacement, you get the work, or basically work per unit time, that is the power, the compressor power in watts or kilowatts, whatever it is. Okay, so the spring balance gives me the reading of the force which is acting on the piston shaft into the displacement. That will give me the work, and motor RPM known, so I know the time factor. So this force, work per unit time, that will give me power. Is it fine? Any doubt to anyone?
No, sir.
लोड दिलाय ना आपण. पण आता गॅस नाही त्याच्यामध्ये कसं?
सब रीडिंग समझ में आ गई? Fine. Okay. Any doubt to anyone? If you
No,
have
sir.
any doubt, you can ask. We can discuss. So in the next session, I will give you the readings. One for the condenser pressure change, the other for the evaporator pressure change. Okay. Now we know the theory. If we change the condenser pressure, let's say increase the condenser pressure, then COP has to reduce, correct?
Yes, sir.
Evaporator constant, condenser increasing, area under the curve increasing, so work increasing means COP lesser. And if we increase the evaporator pressure, condenser same, evaporator increases, so area under the curve reduces, your COP increases. I hope you recollect this. अगले हफ्ते में आपको पढ़ाई करनी है. Next to next week is MST. Right ना?
Yes, sir.
So if I increase the condenser pressure, COP reduces. If I increase the evaporator pressure, COP increases. So that is the practical validation of whatever we have learnt in the theory. तो वो हम करके देखेंगे using this particular setup. Now the thing which I asked to even the offline people also. Let me share the क्या कर सकते हैं इसको. हाँ, this experimental setup diagram only. This is the best thing for explanation. Yes. I asked the same question to offline people also. I'm now asking you. So let's discuss with respect to this figure. Is the screen visible to you? Can you see this schematic?
Yes, sir.
So now you got the essence of the vapor compression cycle, how it works for this particular setup. Now how you change the pressures, evaporator and condenser. So for that, this evaporator, can you see the cursor moving here?
Yes, sir. We can see.
So this is my evaporator, correct? DC heater लगाया हुआ. If I want to change anything related to that, it is related to this, what I can say, knob to change the heater, correct? If I change, if I rotate the knob, the heater will be changed. Input, heater input, correct? So I use the same knob to change the evaporator pressure. How, that you have to tell me. And same logic, my condenser is water cooled. The mass flow rate of which I can measure over here. So if I want to change the condenser pressure, I have to change the mass flow rate. Now how the mass flow rate of the water changes the condenser pressure? These two things you have to tell me. It may not be possible right now, I agree. So I will share the what we call this as journal write-up, lab write-up. Okay, in that the theory is explained for around 5 or 6 pages, whatever, and you can go through that, read it, and then tell me that by merely rotating the knob for the input power for the evaporator, how the pressure changes. And here also by merely changing the mass flow rate of the water which is used for condenser cooling, how I can change the condenser pressure, because water is outside, refrigerant is there inside the condenser. So whether I change the mass flow rate of the water from outside, how the condenser pressure changes, that is something which you have to tell.
Sir, we can increase the temperature
Of what?
of the water inside the condenser.
How?
Uh, Sir,
There is no
I
heater.
don't know that.
There is no heater here. The schematic is in front of you.
Oh.
I have only one heater, that is evaporator. So that is why one knob. This is motor input. This is evaporator input. And there is another power supply that is towards this motor. It's coupled with the dynamometer and the shaft of the compressor. So I'm not expecting the answer right now immediately. I fully agree. I will share the write-up. You have to go through that and then use some thermodynamic logic how one parameter affects the conditions, the state of the other. ओके अगर किसी को अभी समझ में आता है फिगर देख के तो वेरी गुड, नहीं आता तो बाद में बोलो, आई डोंट माइंड. अगर किसी को अभी आता है तो बोलो 10 out of 10 without any viva. Unless and otherwise I give you some incentive, you will never work. बोलो golden chance, no viva and directly 10 out of 10 within next 5 minutes. Anyone wants to try? Entire schematic is in front of you. You have to just apply a few thermodynamic laws and find out. Nobody wants to take a chance? Fine, you read it afterwards. Yes.
In case of evaporator, when we increase the temperature, when with means critical temperature, critical pressure should change with temperature, right? So if we are increasing the temperature,
1 minute. Critical pressure and temperature has to change. Why?
so phase change will happen at a constant temperature or pressure, right?
Huh.
So
Critical pressure and temperature are fixed. They are independent of anything happens. That is the apex, the peak of the dome. So whatever happens inside the dome, critical pressure and temperature are same. Critical pressure of water, for example, is the locked one.
basically the temperature or pressure where the phase change is happening, they
Hmm.
would change, no, with pressure and temperature. So basically, if we are increasing the temperature, the pressure for which the phase change should occur, that should decrease.
But how? I increase the temperature. Let it go to superheated phase. Why the pressure would change? That
Sir,
is
because it's in saturated state. So if you are increasing
how
the
you will
temperature,
maintain. How you will maintain every time is a saturated
sir, because
state.
it's a mixture, like we are getting vapor and liquid now.
So
So, sir, so if we are inside the dome, so if we increase the temperature, then our pressure will also increase, because that is it will follow a straight line thermodynamically, sir.
focus about process 4 to 1.
Sir,
Huh.
but process 4 to 1 will be for this, no, sir, throttling one.
That is 3 to 4.
3
4
to
to 1
sorry,
is
sorry, 4
evaporator.
to 1. Oh, yeah.
So 4
Okay,
to 1
okay.
is a
So
constant
then,
pressure, constant temperature, since it is inside the dome. Now I am
okay.
changing the heat content, heat input. तो क्या होगा, ज्यादा से ज्यादा वो बाहर चला जाएगा, सुपर हीटेड हो जाएगा. Compressor inlet would be superheated. Why pressure would, or rather how pressure would change?
सर बट अगर सैचुरेटेड में रहेगा तो सर ऊपर ही रहेगा ना, मतलब
Saturated में लाओगे कैसे? How you will be so ensured that every time it is in saturated one? What is the guarantee that the saturated condition only prevails for the inlet to the compressor? How you will ensure it?
सर थ्रॉटलिंग का इनिशियल लिक्विड ही हो कंप्लीट.
हाँ, ओके.
तो सर वो सेंसिबल हीट इतना नहीं होगा कि वो एंड पे चले जाए सैचुरेटेड के, वो बीच में आके ड्रॉप होने वाला है.
No, not getting. Your saturated liquid point H3 and H4 is same as H3.
Yes, sir. Yes, sir.
Then
Sir, so we'll ensure that our H3 is not such that it will drop at the saturated vapor part of the condenser.
saturated
Vapor
vapor.
Yeah.
H3 saturated liquid.
Yes, sir. So, sir,
Saturated vapor कहाँ से आया?
H3 saturated liquid. So, sir, when it will follow the throttling process, it will obviously fall in the middle of the dome. That is the saturated part, sir. So, sir,
No, that is two-phase, not saturated.
Yeah, two-phase mixture. So, sir, by increasing that temperature, it has only one way of what do you call? The path will only follow one way. That is
How and why?
because sir, wait a minute, sir, I'll draw and show you something, sir.
ठीक है. Should I stop sharing the screen? I think you are now familiar with the diagram. Should I stop sharing the screen? This diagram is more than enough for you to recollect.
Yes, sir.
You can draw it here online also using that board, blackboard, whiteboard, whatever.
Yes, sir. Sir, I'm drawing on that only, sir. So, sir, I was saying that. Sir, can you see that?
No, at least I can't see. Have you shared the screen?
Sir, I guess you have to open that link only. That is on. Okay, sir. I'll share the screen only, sir.
Okay. I opened the file. There is a vertical line y-axis, horizontal line x-axis,
Yes, sir.
and some
So
dome.
this is dome. Okay.
Then
So, sir, this is our process. Okay. So if we increase that evaporator pressure, so it will go this way.
the line which I have drawn is so on the top side that it looks like a condenser pressure. Where is the evaporator?
Sorry, the evaporator is downward. Okay. So if
BMW, ऐसा थोड़ी चलेगा.
So, sir, I was saying that throttling may it will drop here. So if we increase the temperature, so this is our isotherm.
Are you drawing a pH chart or a TS chart?
Sir, T is constant, so PV पकड़ लो sir.
PV.
PV isotherm.
PV में ऐसा कैसा फिगर आ गया?
PV हुआ ना सर?
PS नाम का कोई चार्ट ही नहीं होता.
वही PV है ना?
अरे पीवी में टी का वो अलग आएगा ना.
PV में हाँ T would be like
this only ना?
आएगा मिरर इमेज आएगा.
Sorry.
ये टीएस बनाया ऋतिक.
Okay.
TS बनाया तो then the horizontal line, sorry,
TS.
the inclined line for the throttling.
TS, sorry, isentropic, sorry, TS. So, sir, अगर
in TS your compression process would be vertical.
हाँ, तो ये रहा.
And then throttle process would be inclined towards the right hand side.
Yes, sir. Sir, मैं बोल रहा था कि if we increase, you are saying evaporator pressure with the help of a knob.
Okay. ठीक है. हाँ.
तो सर वो ये ऊपर शिफ्ट हो गया.
होगा कैसे? I'm just rotating the knob. How it would get shifted in upper direction, whatever lower direction. That is the question. वो होने के बाद क्या होगा वो तो हमें पता ही है. That we have already learnt in theory. What happens to the COP and etc. etc. I'm asking that I'm just rotating the knob, which is the heater input. तो अगर ये आपका ही फिगर अगर सामने रखे,
हम्म,
so let's say your inclined dash line, that is throttling, okay, the end point of that line is, let's say, 0.4, correct? End point of throttling, and
sir.
for the compressor inlet is 1.
Hmm.
So if I add the heat input, one will get shifted towards the right hand side. What is wrong in that?
Yes, sir.
That's why pressure would change.
Sir, because it has reached the saturated state.
How can you confirm it?
Sir, by confirming there is no liquid inside.
How?
सर जो भी अंदर लिक्विड है उसको बाहर निकाल देंगे.
कहाँ से? किधर है ऐसा कुछ उसमें? I showed you the schematic.
सर वॉल्व था ना नीचे सर, वो उधर
है?
वॉल्व नहीं था क्या?
वो वॉल्व तो कंडेंसर के बाद था.
ओके
सबसे नीचे.
सर क्वेश्चन एक बार रिपीट कर सकते हैं, नेटवर्क का इशू है.
For the evaporator or the condenser, am I audible to you now? Whether it is a evaporator or the condenser, what are the technique through which you are changing the pressure? The one which we use over here for the evaporator, it is the heat load. Am I audible clearly or not?
Yes, sir. Yes, sir. You are audible.
For the condenser, it is the water flow rate. Water is used for the condenser cooling.
Yes, sir.
Refrigerant से कोई लेना देना नहीं है. Water is flowing from outside.
Yes, sir.
Right? So then how the pressure of the refrigerant gets changed?
Okay, so sir, you are saying that how do we ensure कि ये यहाँ पे पहुँच गया point saturated के बाहर? How do we ensure that?
Any point, whether it is saturated or superheated. How will you ensure it? And even though you ensure, then how the pressure would change? I add the heat. क्या होगा? Saturation तक horizontal जाएगा.
साइकिल ऐसा हो जाएगा.
उसके आगे ऊपर चला जाएगा.
Okay.
So read the manual which I will be sharing very soon, and then try to find out. If you can give the answer, very good. Fine.
Yes, sir. Yes, sir.
So I have to put this window off right now. Anybody wants to know anything further?
Sir, sir, once again, if you can put the question also with that manual, that would be great, sir.
है?
सर मतलब वो क्वेश्चन समझ में आ गया, बट सर वो ऐसा रिकॉल करने के लिए if you put the question again, that will be good, sir.
ठीक है, लिख देता हूँ. उसमें कौन सी बड़ी बात है? गूगल क्लासरूम में ही लिख देता हूँ.
Yes, sir. Yes, sir. Thank you, sir.
करो. Think about it. How practically what thermodynamic process getting executed, and then tell me. फेस चेंज है, मतलब लैटेंट हीट है, सेंसिबल हीट है, क्या है? सोचो कैसा है, क्या है. दैट्स नॉट ट्रिकी, दैट इज सिंपल. कैसा है, हाउ इट इज गेटिंग शिफ्टेड, हाउ इट इज कंट्रोलिंग द प्रेशर. इट्स क्वाइट ए कंफ्यूजिंग थिंग ना. मास फ्लो रेट ऑफ वाटर एंड रेफ्रिजरेंट ऑफ प्रेशर, सॉरी, प्रेशर ऑफ रेफ्रिजरेंट, क्या कैसे लिंक है? That is what is you have to think of.
सर इवापोरेटर के केस में ऐसा सोच सकते हैं कि जो पहले नॉर्मल जो प्रोसेस हो रहा था, जो फेज चेंज का प्रोसेस हो रहा था कांस्टेंट टेम्परेचर और कांस्टेंट प्रेशर पे, अभी हमने क्या किया है कि हीट लोड बढ़ाया है ना सर. तो हीट लोड बढ़ाने से बेसिकली अब वो इनपुट ज्यादा लेगा ना सर.
लेने दो ना, सुपर हीटेड होने दो ना.
हाँ सर, वो सुपर हीटेड नहीं होगा ना सर, क्योंकि उसको जो सुपर हीटेड वाला पार्ट पे जाने के लिए उसको कांस्टेंट प्रेशर मेंटेन, मतलब कांस्टेंट प्रेशर पे रहेगा. बट और जब तक वो सैचुरेटेड है कांस्टेंट टेम्परेचर पे रहेगा. और वो प्रोसेस मतलब अब अपना जो वो पार्ट है वो insulated.
You mean to say that if I continue on the same pressure, it would be superheated? You change the pressure and comes back to saturation.
हाँ, मतलब सर वो पूरा इंसुलेटेड है ना वो सिस्टम. तो अपना प्रोसेस सर फिर वो आइसेंट्रोपिक वाला पाथ लेगा ना सर, rather than following the कांस्टेंट प्रेशर और मतलब रूम के अंदर
Isentropic is for compression. We are talking about the evaporator.
yes sir but अच्छा why the line is getting shifted up or down ये ना sir?
You are saying that if I continue with the same P, then the final state would be superheated. What you are doing is taking out that heat, bringing back the position to the saturated one, and at the cost of increasing the pressure. So how it would happen? Now you got the question clearly, I guess.
yes sir
Superheated, I can say क्या बोलेंगे उसको, heat, superheated heat जो भी है is equal to the saturation plus increasing pressure.
yes sir
How it happens? Find out.
चलेगा
ठीक है? Okay. Anyone else having any doubt, or otherwise we will end the meet? Your all entire vivas, whether it